Hi everyone. Today I wanted to go over the last of the three main trig functions you need to be familiar with. So we're looking at 13-6, the tangent function. Okay, so before, when we looked at our unit circle, right, we were able to find all the different values of different angles. And from those, we were able to get the cosine values and the sine values. So remember, for example, it was always cosine of x, a different color. We always did cosine was x, and sine was the y. Okay? And we practiced that quite a bit. And so right below here, you can see, and I just wrote down little equations right here. You can see that x is equal to cosine of theta, y is equal to sine of theta, and then our last one, tangent, is just a ratio of the two. Tangent of theta is equal to y over x. So let's practice with this a little bit. So to find tangent, basically, without using a calculator, of course, you need to find cosine and sine first, and then you just do a little bit of math. So let's work through this. Let's work through some of the most common angles. So I wrote them down right here. And you should, by this point, be able to find the cosine and sine values of these. All right, well, let's kind of walk through them just in case. So, for example, 0. Well, 0, well, where is it? It's right here. And, well, cosine is 1. Sine is y. So there we go. And well, what will our tangent be then? Well, it's y over x. 0 over 1, tangent is 0. Pi over 6. Pi over 6 is 30 degrees. I drew it in. It's this point right here, okay? And if you don't remember what that is, I wrote it right there. So for pi over 6, x is square root of 3 over 2. And so sine will be 1/2. Okay, now the tangent is going to be 1/2 over the square root of 3 over 2. A little bit of math required here. So if you want to simplify this, well, I'll just do it down here. So 1/2 divided by square root of 3 over 2. It's a complex fraction. That's the same thing as 1/2 times this, 1/2 times, undo that, the reciprocal, 2 over the square root of 3, 2's cancel, 1 over the square root of 3. Now, you don't want to leave radicals in the bottom, so multiply top and bottom by a square root of 3. And so ultimately, that is a square root of 3 over 3. And that's the hardest one. The rest of them are easier than this. All right, so that's the square root of 3 over 3 for pi over 6, 30 degrees. Next up is 45 degrees, pi over 4. Where is that? Well, it's right there. And remember that square root of 2 over 2 and square root of 2 over 2. Pretty easy. Oops. Go back a second. Okay, over 2. All right, now tangent is just y over x once again. Well, square root of 2 over 2 divided by square root of 2 over 2 is 1. And then pi over 3. Let's see here. Now, I didn't write it there, but remember pi over 3 is just kind of always going to be the reverse of pi over 6, right? This is 30 degrees. This is 60 degrees. So this one has to be just the other way around. So this one's going to be 1 over 2. This one's going to be square root of 3 over 2. Okay, so this one is a little bit easier. If you divide the square root of 3 over 2 by 1/2, well, the 1/2s basically cancel. And you just got square root of 3. Okay? Now, let's look at one that's a little bit tricky. Let's look at pi over 2. Pi over 2 is right here, right, at 90 degrees. Well, with this one, what is my x? X is 0. 0. Y is 1. Okay. Uh-oh. What happened? 1 over 0. Not good. This is undefined. So tangent, unlike sine and cosine, is undefined at certain places. Particularly whenever cosine is equal to 0, tangent is going to be undefined, right? Because you're trying to divide by a 0. And you can kind of, those are the most common values right there. And all the other ones are going to be basically the same values as these. So if you're looking at your answers for tangent, without doing it, without having a calculator, of course, basically your answer is going to be either 0, square root of 3 over 3, 1, square root of 3, or undefined. And of course, depending on your quadrant, these three right here could be positive or negative. Okay, kind of depending on whether y and x, cosine and sine, are positive or negative themselves. Okay, so be a little bit careful about that. Let's finish up the last two. So pi is right here. What is that? That is negative 1, 0. Okay. Negative 1 and 0. That's going to be, well, y over x. 0 over something is always going to be 0. And the last one, we're going to be at 3 pi over 2, 270 degrees. Again, that's flipped around again. That's going to be 0, negative 1. And here again, you're going to be undefined. Okay, so those are just some sample values. Now, what does the graph of this look like? This graph actually looks quite different than sine and cosine. Okay, so remember that when we worked with other equations, whenever we had something that was undefined, that typically meant you're going to have what's known as an asymptote. Okay, so I'm going to draw those in. Notice I have an undefined value at pi over 2 and at 3 pi over 2. So I'm going to put in dashed lines to indicate that is an asymptote. All right, so these are vertical asymptotes that exist. Undefined values. Okay. Now the other ones, I'm just going to plot points a little bit just to give you the general idea of where the shape is coming from. So 0, what was that 0? It's right there. Pi over 6, well, it's like a little bit over. Square root of 3 over 3 is not a big number. It's less than 1. I'll put it right about here. Then I'm going to go pi over 4, which is kind of in the middle here, is exactly at 1. And then pi over 3, which is over a little bit more, is the square root of 3. Square root of 3 is about 1.7, which is kind of up there. So notice, the tangent goes above 1. Sine and cosine, unless you transformed it in some way, always was between negative 1 and positive 1. Not so for tangent, right? Tangent can actually go to plus and minus infinity, depending on how close you get to the asymptotes. What does the curve look like overall? Well, you can see in your book, but the general idea, and it goes both positive and negative, is it looks something like that, right? So I'll draw it in over here as well. I'll try to do it a little better. Oop. So what does it look like? Kind of a curve. It looks kind of like that. Okay, don't cross the asymptotes. And another one will appear kind of like right there. Okay, so the book does a better job. I'm just doing kind of freehand right here, which I don't make it look very good. So actually, let me draw that. This one's really messy. I don't like how that looks at all. But the general idea is you can look at the textbook. Whoop, put that back in there. Is that curve again? It's going to look something vaguely like that right there. That's better. Okay, and I'll do it better on the other side as well. So it's this is kind of a nice smooth curve. Looks something like that right there. Okay, and something vaguely like that. Okay. Now this curve, you notice again repeats itself multiple times, just like sine and cosine. So essentially, you see this asymptote right here. There's another asymptote right there. This whole piece right in here is a cycle of the graph. Okay, that piece right in here. So there's one cycle. There's another cycle here. There's going to be another cycle there. And you're going to keep on going to the left and right, repeating forever, just like you did with sine and cosine. So let's look at the actual equation now. Okay, so we got y is equal to a tan of bx. I'm going to tell you right now, for tangent, a doesn't mean a whole lot. If you have a negative value in the equation, that'll kind of flip it around the x-axis. However, the concept of amplitude doesn't mean anything with regards to tangent. Okay, because the tangent function does not have a minimum and a maximum. It goes up and down forever, basically. Okay, so no, you don't really have to worry about amplitude, but you do still have periods and cycles. And where are the periods and cycles? Pretty easy to find. Pi over b is going to be your period. That's the length of your graph. And one cycle will always go between this right here. So one cycle will always be between negative pi over 2b to pi over 2b, right? And so for this basic graph right here I drew before, well, what do you notice? This is this basic y equals tan x tan theta graphs. So b is effectively 1 here. So that means the period of this graph is pi over b, or pi over 1, or pi. And so if we look here, this graph goes from pi over 2 to 3 pi over 2. And that's 1 pi, right? And also, you're going to have a cycle that goes from, let's see, again, b is 1, negative pi over 2 to pi over 2. And that's what you got here as well. I kind of accidentally erased a little bit of it here. But your set of asymptotes is going to go from negative pi over 2 here to pi over 2 there. Okay? And so if I wanted to put in another asymptote, I could sketch that in as well. And that will be there as well. Okay? And you notice that the length of this graph, also, you go from negative pi over 2 to pi over 2. Again, that's pi, so that's your cycle. Okay? And also, if you want to find the locations of the asymptotes, well, they're always at the end of each cycle. All right? So you can always find your first set of asymptotes by using this right here. And basically just extend it out from there. I'll show you an example in a little bit. So let's look at some couple problems here. Now, the first set of problems, for example, 9 through 15, find each value without using a calculator. Basically, you just have to do what I did over here, right? You find the sine, find the cosine, divide them, okay? And that's how you do that. Now, these guys, 19 and other ones, actually ask you to find some information about these. So let's look at 19. So y equals the tangent of 3 theta over 2. And I want to identify the period and determine where 2 asymptotes occur for each function. Pretty easy. First, mainly all you need to do is get b. B is 3 over 2, sorry. And then my period is going to be pi over b, which is pi over 3 over 2. And you can kind of flip that around, and you get 2/3 pi. So that's how long each section of your graph is going to be. And then 2 asymptotes, basically you can get where your cycles are. So your first cycle, remember, is always negative pi over 2b to pi over 2b. And basically you just plug in. So you get negative 2, so that's annoying. Okay. 2 times, what is it, 3 over 2? And the other one, and it's always going to be symmetric like this, 2 times 3 over 2. And so your two asymptotes are going to be where? You got negative pi over 3, and your other one's going to be positive pi over 3. All right? And you notice that that is, the distance between these two is 2/3, and that's your period. Okay, so you always should have that relationship. So this is the location of your two vertical asymptotes. So my vertical asymptotes, if I just want to be a little more specific and write it out, is going to be at my vertical asymptote is going to be at x is equal to negative pi over 3 and pi over 3. There's actually an infinite number of these. And basically at the end of each cycle, you're going to have another vertical asymptote. So we could keep on going. If we just added 2/3 pi successively to each of these guys, like that one right there. If I just took pi over 3 plus 2/3 pi, well, that's pi. Well, that's where my next vertical asymptote would be. And then I could just add another 2/3 pi and another 2/3 pi. And I'd find many, many different vertical asymptotes up to infinity. Okay, let's look at 23 now. Now this one, we actually want to sketch a graph. So before we get started, let's find the period and our cycle. Okay, so this one's pretty straightforward. Let me see here. Y equals tangent of 2 theta. Well, that means b is 2. So my period is going to be pi over 2. And the cycle here, easy enough, it's going to be pi over, well, negative 2 times 2 is negative 4. And positive pi over 4. Okay, so you need to graph it from 0 to 2 pi. Alrighty, so looking at my period and my cycle, it looks like I need to count by fourths. Okay, so because my smallest unit here is fourths. And so that's how I'm going to segment it up. And so I'm going from 2 pi, so it looks like the middle of the graph is kind of like right there. There's pi. Over here I'll put pi over 2. Here is 3 pi over 2. And these are all my fourths right here. Okay. All right. So first thing I recommend you do is put in your asymptotes. Okay. Again, where are those? Well, they're at the end of each cycle. So where is that guy? Here we go. So pi over 4 is an end of a cycle. So I'm going to put a vertical asymptote right there. Pi over 4 is kind of basically right in the middle here. Okay. And I have another cycle, each pi over 2. So what I'm going to do is add pi over 2 to pi over 4. That's basically 3/4 pi. So that means I'm going to have another one right, I have another one right here. And basically every pi over 2, I'm going to have another cycle. Another one right there. And another one right there. Just like that, okay? Once you got your asymptotes in, it's pretty easy to draw because the graph just repeats itself. And so now I'm just going to sketch it in. And so it always starts going up at 0. So it'll be half of a graph right here. So it'll look something like that. Then this next one, it's going to come up from down here, cross there, go up, and it just repeats forever, basically. There you go. Another one, like that. And the final one is kind of getting chopped off. Only going to get half of it. And kind of like right there. Okay. So with the tangent graph, basically, unless they're shifting it around in some way, this first part of it, you're going to have half a cycle. So basically it's going to start at 0 and go up. But the whole cycle, when you're starting the next one, make sure you're going to have the negative stuff included as well. All right, but it just repeats over and over and over again. Okay. So the trickiest part, again, finding the period, that's the length. So you notice that each one of these is exactly pi over 2 long. And then if you draw on your asymptotes, it's a piece of cake. All right, once you got your asymptotes down, you can just sketch in the curves. And once again, this one starts, first one's at pi over 4, which is right there. Okay, I add pi over 2, next one is there, add pi over 2, next one is there, next one is there. Okay, and you can stop. The next one would be greater than 2 pi, so no need to draw that. Okay, so I'm going to stop right here. Please let me know if you have any questions, and I'll talk to you guys later. Thank you.